Hi everyone, and welcome to my computer graphics final presentation. For my final project, I decided to explore ray tracing. In addition to completing the tutorial which I was following, I also implemented this checkered pattern, which is shown on the screen, as well as some animations. With this animation, you can see that the sphere is simply flickering between two locations on the screen. This is because with this animation, only two images were used. In this next animation, you can see the sphere is slowly falling down and then bouncing back up to its original position. In this next animation, you can see that the sphere is falling down more smoothly than in the last and then bouncing back up to its original location. This was achieved by both varying the number of images which were used in the animation, as well as varying the difference in between hops that the sphere was making in each image. Now to get into the code. First, I'll discuss how ray tracing works in general in our implementation and then move into how the materials are generated. So essentially with ray tracing, we are generating rays with the series of for loops in our main function and then determining how our objects are colored based on if these rays hit our objects in our color function. In our color function, we determine if a ray hits anything in our world space, which is a list of hittable objects, which in our case are always spheres. If any object is hit, then we determine the color of the point which is hit based on the material that that object is made out of. With each material, we have a scatter function, which is determining how the ray is either absorbed or scattered by that material. In the case of a metal material, we want the ray to be reflected. So we take the input ray, as well as the normal of the surface which we are hitting, and determine the reflected ray. This reflected ray is then output via the scattered parameter, which is used back in our color function in the main file. So back in our color function, we determine the final color of the metal sphere based on the color of the metal sphere itself, as well as the color of anything that is hit by that reflected ray. So this is essentially taking the color of anything being hit in that reflected ray and putting it on our metal sphere, giving it that mirrored effect. We also have a checkered pattern, which there's something special happening here in terms of determining when the sphere should be black and when the sphere should be white. The sphere is determined to be black or white based on a spherical mapping, so this is taking the 3D points and putting them into 2D coordinates, which then are used to determine if the sphere is black or white based on a 2D grid of a checkered pattern. So this is taking the mapping and then determining the color in the 2D space and then applying that to the 3D space. This checkered pattern is used here on the base sphere, and then in some smaller spheres in this next example, and then here's a final example with a few more spheres in the space. Something I would have liked to improve upon in this implementation is the runtime so that I could have completed more complex scenes with more spheres in them, but that's all I have for you for today, and I hope you enjoyed this video.